All right, look what we got in. This is the cheapest 6 kilowatt hybrid solar inverter, I think, in the US. Now, I might be mistaken, but this inverter sells for $300, and it's supposed to be a 6 kilowatt hybrid. Let's open the box and see what we got here. And here's what it is. It's a Vevor. This is going to be interesting. Six kilowatts. It's an all-metal case. No plastic here. All right, before we get too deep into this, I just want to say this is not a recommendation from me. We're just going to take a look at this, see what it's made of. We'll tear it down. And then in an upcoming video, we'll power it up, put it through some stress tests, and see if it actually sustains the 6 kilowatt claim. All right, let's get into it. Says Vevor, tough tools, half price. Hybrid solar inverter model EM62000-48L, 220, 230 volts AC, 50-60 hertz, 6,000 watts. Battery 48 PV, 60 volts to 500 volts. Charging current 120 amps maximum. Use ambient temperature -10 to 50 C. And will you believe it? It's made in China. It's got some filtration in the air inlets here. Is it? It must. These fans must suck the air through this way. Otherwise the filters would be not in the right spot. Let's see here. I think what we're going to do, we're going to open the case up here. Let me get something to put the screws in. You guys see all right? Yeah, I guess so. All right, first we're gonna open the bottom. See what we got there. I don't know if you can see that, but we've got a AC in, line neutral, AC out, line neutral, PV in, plus minus. So this thing, it's not split phase, okay? If you wanted 120 volts out of this, you'd have to hook up a transformer. But for the application I'm thinking of, I only need 220. So let's continue on here. I think we must have a screw right underneath here. Warranty's void. Now we can see a little better. See what these FETs are. G60T60AK3HD. Someone look that up. Let's see what if we can read the other ones. I don't know if that's the. I think that's the output side. Can't see here. K100E10N1. Can't read those down there. Looks like probably the same Samexon caps. High quality. 470 microfarad at 500 volts. These are 300 microfarad at 63 volts. 3300 microfarad at 63 volts. These are the same, 3300 microfarad, not 330. Let's investigate what those, if those are FETs or what they are. All right, I've been busy here. I took the main board out. I didn't want to bore you with all that, a bunch of screws in there, but what I've been able to determine here is that these 4 IGBTs, and they're all of these are IGBTs. There's 4 of the G75s here, and then we've got 5 of the G60s that I saw when it was all together. But so these 4 here seem to be the H bridge in the output stage, and then over here these guys are FETs on the MPPT and battery charging stage. Then what else do we have? Oh yeah, on the back you've got, these are the FET drivers. There's a couple more drivers over here. I don't know what those are for yet. And then we've got the microprocessor right there. And I'll put up what that is. This little daughter board I haven't really looked at yet. Not for sure exactly what ACSPS here. We have to see what that is. But you know, another interesting thing is it's got an RS485 port on it. Now I looked at the instructions. Do I have them here? No. The instructions are listing compatibility with the Pylon US 2000 lithium battery. So I don't know if there's any other batteries that it's compatible with, because that's the only one that's listed in the here, I'll show you. It's listed in the instructions. It's going to be interesting to see if we can get it to work with any other batteries. But as of right now, it doesn't seem to be too bad of a cheap inverter, and I mean it should be relatively easy. I mean, especially if you have a problem with the FETs or the IGBTs over here. It's going to be easy to repair this unit. You know, everything's on one board, easy access. You just pull the board out, desolder the bad components, and plug in some new ones. And that's usually what goes bad, are the IGBTs. Another thing I noticed, doesn't this whole thing look very familiar? Now, I haven't looked inside one of the EG4 MPPT chargers, but the outside case is an exact match. Let me put that up here for you. And then I also noticed that a lot of the what is it, PowMr or PowMr inverters are using the same exact case. It's got the same exact filters on the side. It's got the mounting strip on top. It's got the same layout of the fans and everything else. Pretty much the same. The only difference is the front panel has a different LCD. I would like, if somebody has a PowMr that's not working, or the EG4 MPPT charger, if someone has one that's not working, if you could take the cover off and post some pictures, that would be very interesting. I don't know if I'm going to do a whole reverse engineering project on this thing. I think I'm going to put it back together. I've got the basic, you know, concept, what's going on here. So I'm going to put it back together, and I have to get some 48 volts. I can't plug one of my high voltage batteries into it. So I'll have to come up with a 48 volt battery, and we'll do a test on it, and do some load tests, see what it does. It seems like, you know, the heatsink seems a little bit skimpy, so we'll do some testing on that and see what the temperatures are, if it can actually sustain 6 kilowatts or not. I'm thinking probably not, but you know, if you can get 4 or 5 kW out of it continuous, it's still a good deal at $300. All right, guys, that's going to be it for this one, and hope you enjoyed it. I appreciate you, and we'll catch you on the next one. Adios.